Let's solve today's LeetCode problem. Let's see what's in the store. And we have 20 minutes to solve this. Let's see if I can do it. So I'm reading through the problem. You're given an m into n matrix or grid, and each cell of a grid represents a street. Fine. Each cell. Hmm. The street of a grid ij can be 1, 2, 3, 4, 5, 6. Hmm. Okay, so it can be from 1 to 6, which means a street connecting the left and the right cell means the street connecting upper cell and the lower cell, which means the left cell and the lower cell. Oh, okay. Right cell and the lower cell. Okay, basically this is how it's going to be. Like connect left right, connect up down, connect this, connect this, connect this, and connect this. Got it. So you will initially start at the upper level, 0 0. A valid path in the grid is a path that starts from the upper cell and ends at the bottom right cell. The path should only follow the streets. Yeah, makes sense. So first thing I see is there should be this or this at the top. No, it can be anything, right? So it's just about connections. So this is the grid. So 2 up down, then 4, then 3. So like this, like this, like this, like this, like this. Just thinking, is it possible to have two paths in any way, in any way? That's what I'm thinking. So if it was like this, the only way is to go down. If it was like this, only way is to go left. Hmm. If and okay, I'm thinking, is there a way to go in a loop? So for example, let's see, Excel draw, reset. Where is reset? So what I was thinking is, this is the grid, right? But we can be in loop if, let's say, this is the street and then this is the street. Let's say we also have another row here, and then this is the street, and then this is the street. So if we always keep checking next, we're gonna go in loop. So in that case we need to stop. And another thing I was thinking is there a way that we can have two choices at any point? Have two choices. So in this case there is no choice. Either we can go down Oh, we can have two choices. So if this is like this, we are here, we can go down or we can go left. So it is possible to have two. And let's say if we go like this, we reach in just one. But if this is going to be like this, then we can't reach from here. Makes sense. So at a point we can go two sides, but there is no point in going somewhere we have already seen. Like from here we can go upside and this side, but there is no point in going this side. So we only need to go this side. Okay, so that means I need to have some correction, which is, so 4 means street connecting the right cell and the lower cell. Okay. Okay. I think it's quite simple. It's like finding the path where the only option is right and left. Sorry, right and down. But this is a bit complicated. Finding the path, but based on the previous value. If previous value is 1, we only can go up or down. If it is 2, we can go left or right, something like this. We only choose, and then we need to keep track of seen places, and we need a recursive function um, to yeah, go deep. Okay, makes sense. So I'm thinking of a DFS, deep depth first search, kind of a traveler, and keeping track of seen streets. And in either case, I can just go deep, right? So let's take this example, this one. So I start here. Let's say my algorithm starts with the left. So I go um, from here to this side, right side, sorry. And then I go maybe multiple right sides, it's possible. And then I cannot go any further right, and this is also not the end. So I return false from here, false from here, false from here. Now I can only go this side. So I will go this side, and I will go this side, and I will return true, 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 which makes it true in the end. Yeah, so recursive function at any point take two decisions, and that's it. I think this is how I will code. I don't know. I'm not getting anything else. So let me just go ahead and start writing the code for this. So what I have in mind is a recursive function that I said. Let's keep it simple for now. So let's keep it, call it DFS, and it takes a row as int and column as int, and its value is already present. And this returns boolean. Okay, so first is if we are not in the correct indices, so grid dot, so are not in grid dot indices, or C not in grid of 0 dot indices. This is a Kotlin way to quickly check if something falls in the particular area. So if r is, let's say, -1, this will go false, so we can't go ahead. Or if, so in this case we need to return false, right? Or grid of r comma c is in, not grid, so okay, r comma c. So I'm thinking I should see this grid as seen, right? So what I can do is pair of r comma c in scene. So I have to declare a well, scene is equal to mutable set of pair of int comma int. So if it is in scene, then we return false, right? So let me just return false here. This is good. If it is not, then we check if we can go, no, we need to add this to scene first. So scene dot add pair of r comma c. And then, so this is the first thing. So we have seen this. Now based on this value, we can choose to go somewhere else. So when grid of r comma c, so if the value is equal to 1, then we return from here. So in this case, we can go left and right cell. So we can do DFS of keep the r same, c -1, or DFS of r comma c +1. So we go left, right. If it is 2, then we go up, down. So we go +1, let's keep it consistent, -1, +1. If it is 3, which means street connecting left cell and the lower cell. So left, which is right case, c plus 1, no, c minus 1, correct. From here I can go this side, so c minus 1 and down, so r plus 1 and c is the same. In case of 4 we can go right, which is plus 1, and we can go down again. Okay, and in this case we can go, where can we go? Something is wrong, let me see. So this side is c plus 1, this side is c minus 1. Yeah, this is correct. So we are checking 4, which is, we can go right side, keep, yeah, and then down, see, that's correct. And here we can go left side, yeah, so that's correct. So here again we can go left side and r same, or we can go up, which is minus 1, and c is the same. And lastly, let's call it else. At the last we can go right, which is c plus 1 this side, and up, so r minus 1. Makes sense, makes sense. So that's it, and I think I need to return DFS of 0, 0. Yeah. So let's see, if I go 0, 0 here, it is in grids, it is not in scene, so we don't return false. We add it to the scene, and then when we do grid of RC, which is, let's take example this one, which is 2, so we do r minus 1, which is up, which is not in indices, we get false, so we go here, we get r plus 1, so this is fine, so we add it here, and then we go, yeah, but where should I, okay, yeah, I need to have the end case, right? So grid of let's take the m and n here. Let's say val m is equal to number of rows, so grid dot last index, or maybe size, let's do that, and val n is equal to grid 0 dot size. At any point if we reach this position, which is m minus 1, n minus 1, then return true. So once we have done this, I think it should be fine. Yeah, it's about 20 minutes. Let me just give it a try and see. Kotlin int, okay, this is equal to not like this, so r equal to m, minus 1 and c equal to n minus 1. Okay, first two cases are fine. Last case, which is 1 1 2. Oh, okay, so I failed this. So it's the case is simple. So it's like this. This is single grid and there are 3 positions. So I'm doing this, and then I'm going here and I'm checking up and down. But I should be first checking if it is like this. I should only go, yeah, I'm checking that, right? Either this or this. So I should first check the next value. Um, okay, that's something I missed completely. Let's see solution. Da 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 da. It's kind of same, right? Scene left, right, left, right. But this left is a bit more complicated. So it is not just uh, the indices part, but it has to be uh, something else as well. So yeah, sorry I can't solve this today, but I had a pretty good intuition. This is still good for me. Not so good for you. But anyways, thank you so much and have a nice day.